And welcome to Naughty Notes. Well, here we go again with another one of our COVID-19 replacement series. This is iSchool that we use in the Anchorage School District. And I'm going to reference our textbook because we use this one, McDougal Littel. And we've got 4 questions in this quiz numbered 903 here. And I'm not going to give you the exact answers, but I'm going to remind you of what you learned earlier. Now, this looks like it's kind of funny. It's in this section, but it goes way back to chapter 5. We worked on this because we constructed. If you read this question, she's constructing a circle inscribed in a triangle. So we've got circles on the inside, we got circles on the outside. We want the circles on the inside. Hey, let's take a trip down memory lane here. You probably remember this. Well, the angle bisectors are going to give us the incenter. So if that's the interior of the triangle, let's do it like this. So remember, you put a compass, you made a random arc like that. It takes 3 swings, that's 1. Then you're going to gap the compass. You're going to put the needle on one intersection. You're going to gap it to the other. And you're going to swing the arc like that. Okay? You remember doing this. And then we put the needle on this intersection, gap it back there, a pure Euclidean construction. And we give it a swing. As we like to say in my class, it don't mean a thing. Ain't got that swing. That's going to give you've got the A, and you've got this intersection of the arcs. Line up Sammy's straight edge, and there you go. And of course, what you've made is an angle bisector. Beauteous. Now, I guess if we just pared it down, let's make it simpler. We'll just put in the compass marks. See, as it shows in your problem, that's the first swing, just showing the parts where it intersects. And then you're going to put the needle, swing one arc, and you're going to generate an intersection and reverse it. And there you go. You got the exact same thing. Now, let's do it one more time so you can kind of get the idea. And again, you're creating an angle bisector. And so if you just see these, those are the compass swings that we've done. Those are the compass swings that will give you. Line up your straight edge, they'll give you that. So you should be able to answer this question now. You've got everything you need. Oh, and by the way, that makes this point called the incenter. You probably remember. And remember, if we gapped our compass properly, that's going to give us the circle on the inside. That was beautiful. Okay, so that should help you by now. I'd hope you can answer question number 1. Let's move on, give you some insight into number 2. Aaron is circumscribed. A circle circumscribed about a triangle. Boy, you got to watch the vocabulary because the triangle is circumscribed, or a circle is circumscribed about the triangle, or it's the same as saying the triangle is inscribed in the circle. Yikes, that looks pretty confusing, but they've got a couple compass swings there. Let's take a trip down memory lane here. Section 5.2. Oh, sorry, I left that off. And I'm going to do it this way. I'm going to put the needle on A. We're going to gap it to C. You probably remember, I'm going to swing it up and down. Oh no, uh-oh, what did I do? There we go. So I swing it up and down. I've got a compass swing there. And then I'm going to gap it the other way. Put the needle on Charlie, gap it back to A, and you see what that's going to get us. Make sure we get those nice intersections. And that's going to give us this line. And so there you go, that line, AC, where that is the perpendicular bisector of AC. I should have put those tick marks in, but I didn't. Now, let's see if I do the same thing, and clean this up a little bit. I'll get rid of that compass, and I'll just simplify it. Those are the compass swings, the intersections that you see. Now, for AB, the swings would be there, and that would give you this line. Again, the perpendicular bisector of AB. And for BC, the compass swings would be there. And again, the three of them are concurrent at a single point. And that intersection is known as the circumcenter. And we put in our compass and let's give it a swing. And now the 3 points of the triangle are contained inside the circle or on the circle. And you may remember from chapter 5, every triangle can be inscribed in a circle. Every triangle can have a circle inscribed inside it. So every triangle has a circumcenter. Every triangle has an incenter. And you'll see that's a little different for those quadrilaterals. But this, again, this will help you out. Now you got questions 1 and 2 all done. Right, let's move on to quadrilaterals. Yay. Now, we used to do this the fun way back in my class there, but I guess we're going to miss out on this, Theorem 1010, and this is on section 10.4 of your textbook, going back to the textbook. At least we're in the right chapter again. And I want to show you the concept here first before we do a problem. I've got 4 points that are on a circle. So I'm going to draw this. In red, I'm going to draw the 2 rays that make angle F, and that intercepts this arc. Now, if I were to take my protractor like this, and I can measure that. I mean, that's the 90, that's 100, 1, 2, and it looks like I'm reading on the outside scale here. And yes, you need to know how to use your instruments. I'm getting 102 degrees. Now, if I were to take the blue, and I'm going to say the blue rays, the blue angle, that is, the angle EDG, also known as D, intercepts that blue arc, which appears to be the minor arc. So let's see if I can put my protractor on this bad boy and line it up like this. And let's see what I've got there. And I can see 60, 75, 6, 7, 8. I'm getting 78 degrees. Well, of course I am. Let's move this protractor out of the way because we could figure this out. We know something. We know the red arc and the blue arc make a complete circle, 180 degrees. And we know that or I should say, since the red angle intercepts the red arc, the blue angle intercepts the blue arc, they're each half of their respective, their intercepted arcs. They must add up to be exactly 180. Hey, that's kind of neat. Now, let me do something else here. I'm going to split the figure this way. And I can do the same thing. If I put that protractor on there, I would certainly measure that to be 96. How do I know? I've done it before. And in magenta, I would figure out that one to be 84. In the end, these two numbers also have to add up to 180. That's a property of an inscribed quadrilateral. So those two, the 2 arcs add up to 180. The 2 arcs add up to 360. The 2 arcs angles add up to 180. In the end, that is your quadrilateral. Pretty neat, huh? All right, well, let's keep going. That's the concept. Now let's apply it to the problem on your paper. Number 3. Well, okay, I'm going to help you out a little. I'm not doing the actual problem. I made this one up myself, but it's similar. So you got a lot going on here. This figure is inscribed. And again, this is section 10.4. That tells me that this angle and this angle, they are opposite. They must add up to 180. That's the only thing that can work because I've got angle R, but I don't, in this case, I don't have a measurement for angle P. So let's go ahead. Angle O and angle Q add up to 180 because they are opposite angles are supplementary. Now I'm going to do the substitution. I'll put in this expression and this expression, add them up, set them equal to 180. Then we're going to simplify. Yes, you're going to combine terms. You've got 5 giraffes and 9 giraffes. You can add those up. I've got 14 x's, negative 3 and 12, and 15 makes 12. And notice when I simplified, I also dropped the degrees sign. You could think of it as dividing both sides of the equation by degrees. And you can combine the x's because you're really solving for an x. You're not solving for a degree at this point. And then it's just algebra. You guys know that because, gosh, prerequisite for this course. And 2-step equation, and you've got a value of x. X equals 12. Not 12 degrees. X is just plain number 12. And, I guarantee you, if this was an SAT question, somebody, or multiple choice question, somebody would put down 12 and you'd get the answer wrong. Because the question says, what is the measure of this angle right here? Well, now you're going to have to do the substitution thing. And, personally, I'd probably substitute into more than one angle. In this case, I substitute into O, I substitute into Q, and I come up with 57 and 123. That checks out because those two numbers are supplementary. And, I could, if we really wanted to, we could also find the measure of angle R. Why? Because it's, we know what the value of x is. So we could solve for that. Okay, one more and we're done. Yeehaw. Okay, on the last problem, we have a kite. And honestly, I don't think you even need to know it's a kite. But since they mentioned it, I want to remind you in section 8.5 of your textbook, we learned about kites. And I got a random kite here, and we've got 2 properties. We've got the diagonal property. And remember, one of the diagonals, the red one, is the perpendicular bisector of the blue. But not vice versa. The blue one is perpendicular to the red, but it does not bisect it. That's an interesting property. We're not going to use it on this one. The other property, which we might want to use, is this one. All right, so we know 2 different things. The diagonals are perpendicular. One is a bisector. And we know that exactly one pair of opposite angles is congruent. And that's it. So let's look at the problem. So you got to figure like this and see, I'm not going to use the exact numbers. You're going to figure it out. But we've got a kite, and it is inscribed in a circle. And I believe you got something like this. They're going to give you this measurement and tell you to find this angle. Okay? So a couple ways you could go. You could say this. Let's suppose that this is 300. I'll just do some hypothetical numbers that I'm sure they're not going to use. Well, you could go 2 ways here. Well, that means that means that this angle intercepts 300 degrees. It's half of that, which makes it this angle's 150. Then the 2 opposite angles must be supplementary. Angle E is 30. Notice we could go the other way. You could say, well, hey, if this is 300, then the blue arc must be 60. And therefore, angle E intercepts the blue arc. It's exactly half, or 30. So either way, you're going to get the same number. And it's up to you. I don't know what you like, what you prefer, but the more tools you have, the better off you are. And the only other thing that's kind of interesting here is, what about DNF? Well, nobody asked, but interestingly enough, no matter where I put these, here, 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 you know something about them. You know that they have to be right angles. Now, I don't think the question's going to ask that, but that's probably the more interesting facet of this. These 2 angles, since they have to be congruent and they have to be supplementary, they have to be right angles. And I say that concludes this quiz. I hope you get them all right. Well, of course you will, and I gave you two chances at it. So get this done, and thank you for watching Nani Notes.